So what then has been the problem with this radioactive tritium? Why have they not been able to deal with that in the way in which they have a lot of the other problems with this wastewater?
Tritium comes in the form of tritiated water, we call it. So tritium is a radioactive form of hydrogen. And what happens is that in a few molecules of water, instead of H2O, you get what we call HTO, which is one of the tritium radioactive form of hydrogen has replaced one of the hydrogen atoms in the water molecule. And that means that chemically and biologically, tritiated water behaves identically to ordinary water. And that means separating that small amount of tritiated water out of that 1.3 million tons of ordinary water is pretty much impossible at that scale.
What concerns do people have about tritium itself? I understand we're going to deal in some depth with the science around this. We know that the IAEA are perfectly happy with this water being discharged. But tritium itself, radioactive tritium, what potential effects, harmful effects, might it have in sufficient quantities?
So like all radioactive emissions, or ones that we call ionizing radiation, and that means they can ionize molecules. In other words, they can knock electrons off molecules and change their chemistry. And in particular, they can damage DNA.
How concerned should we be that the Japanese are, over an extended period of time, we have to say, they will be releasing this tritiated water into the oceans and, some say, potentially into the ecosystem?
We shouldn't be concerned. Of course, we need to check it and check that they're doing what they say they're going to do. But what they're doing is something that happens at nuclear sites all around the world. So nuclear sites generate this tritiated water and they discharge it to rivers or lakes or the sea. And very often at much higher levels than this Fukushima release will be. So there's a nuclear site in China that emits about 3 times more tritium into the Pacific Ocean than Japan will from Fukushima. Our Sellafield site in the UK emits something like 40 times more each year into the Irish Sea of tritiated water. The Le Hague site, a reprocessing site in northern France, emits 450 times more each year into the English Channel. And so, this has been going on for decades, and the radiation doses, both to people and the environment, are really very low. The thing about tritiated water is that, I mean, if you have to emit radioactivity into the sea, then it's about the best thing to emit for 2 reasons. One is that the tritium radioactive decay is very weak. So although it can do DNA damage, you need an awful lot of it to do significant damage to create a significant risk. The other thing is that it doesn't bioaccumulate. So something like radioactive cesium, which was emitted at the time of the Fukushima accident, you would expect to get about 100 times more cesium in the fish than in the water. So you'll get biomagnification. That doesn't happen with tritiated water because, and that's the reason it's in the waste in the first place, is because it behaves exactly like normal water. And so it gets diluted in the food chain by a hugely bigger amount of ordinary water.
So, Professor, those who are making claims about significant risk to the Pacific Ocean ecosystem, they are wide of the mark.
I think they're incredibly wide of the mark. Just to give an idea of this, so the water is going to be treated until everything is below the Japanese guidelines, and it's going to be diluted 100 times before it goes out the pipeline. And on coming out of the pipeline, it'll have. So we measure radioactivity in a thing called a becquerel, and there'll be 1,500 becquerels of tritium per litre of water discharged. And that probably sounds like quite a lot, but the World Health Organization drinking water limit for tritium is 10,000 becquerels per litre, so 7 times higher. So in theory, you could drink this water. There have been dose assessments done, so people do models of where the radioactivity will go, how it accumulates in the food chain, how much people who consume a lot of seafood from that area could get from the radioactivity. And they come out with really very, very low doses. So those dose assessments have been done by the Japanese, they've been done by the International Atomic Energy Agency, and there's also a group of independent scientists who've done a study. And they all find the same thing, that the dose is probably 2,000 times lower than the radiation dose that we all get from natural radioactivity, from cosmic rays, from natural radioactivity in the ground and in the food we eat and in our bodies. So it's not something I think we should can be concerned about.